Alrighty, so in this video we're going to look further at that addition rule with mutually exclusive events and events that are not mutually exclusive. We talked about it in that last video. I want to hit it up again in this video. So remember, when events are mutually exclusive, notice in my Venn diagram the circles never overlap. That means A happens or B happens, but never both at the same time. We can just do the probability of event A plus the probability of event B. Add those two probabilities together, and that is the probability of A or B happening. That is what we call our addition rule. So if I tell you the probability of event A is 0.2 and the probability of event B is 0.3, we can, and we know they're mutually exclusive because if you look above it, you will see that in the instructions and you will see that Venn diagram. I can just do, oops, let me get the pen going. I can do the probability of A plus the probability of B, and that will be the probability of A or B. Because just one of them needs to happen. So if I do 0.2 plus 0.3, that's going to give me 0.5. Notice my probability got bigger because I want one of the two outcomes to happen. Alrighty, so that's how you can do those. And please leave your answer in the correct format with the correct number of decimal places as needed for 13 and 14. Now, notice these events are not mutually exclusive because there is an overlap right there. So they are not mutually exclusive. So we change our rule just a little bit. We're going to add A to B, probability of A plus the probability of B minus any overlap. This is what we call our overlap. It's where they both happen at the same time. That's right there, that much right there. Okay? That's the A and B part. So to find this probability, I am going to do 50% plus 40% minus the overlap of 30%, because 50% of my respondents are event A, 40% are event B, 30% are both. So if I do 50 plus 40, that's 90. 90 minus 30 is 60%. And when you enter those answers, you do not need to put your percent signs, just the values. Now, so remember, if A and B are both mutually exclusive events, they cannot happen at the same time, then the probability of A and B will always equal 0 because A and B cannot occur at the same time. So that would be impossible, which would be a probability of 0. So let's go ahead and complete assignment 14.3 and put those answers into Student View.